Question 14 of the free response. A statistics instructor created a linear regression equation to predict students' final exam scores from their midterm exam scores. So the regression equation was the predicted final would equal 10 plus 0.9 times the midterm. So part A, if Kelsey scored a 70 on the midterm, what did the instructor predict for her score on the final exam? So it's simply substituting directly into the model given. The final exam predicted would be 10 plus 0.9 times her midterm score, which was a 70, and that would give her an overall score of a 73 predicted for her final exam. Part B, Kelsey got an 80 on the final. How big is her residual? This is her actual score. This, remember, was her predicted score. So a residual is equal to an actual minus fitted or predicted. And it must be done in that particular order of subtraction. So we take our 80 that she actually got minus the 73, and she has a residual of 7 points. Those who had the negative 7 interpreted what a residual was in reverse, and keep in mind, as residuals are used, there needs to be that consistency of actual minus fitted or actual minus predicted. Part C, how many points would someone need to score on the midterm to have a predicted final score of 100? And that's just using this model in reverse. So we'll substitute the 100 in place of the predicted score and work backwards to see what they would have needed to get on their midterm. We could use the word midterm there. We can actually make that a variable of x if we want to. I'm going to subtract my 10 first. 0.9 times midterm. Divide both sides by the 0.9. And 90 divided by 0.9 happens to still be 100, which would say if you are going to get a midterm value of 100, it predicts 100 to be on your final exam, which is a pretty clear-cut example of why the professor would have, or instructor would have, created that model.